The broken fragments of Shoemaker-Levy 9 were big enough to remodel life on Earth. Each was being sucked in by the largest planet in the solar system. Each of their fiery descents was another chance to find out what it's really like on Jupiter.
The most amazing thing about Jupiter for us Earthlings is that there's no place to stand. We see clouds. We see nothing but clouds. We don't see the ground because there is no ground.
If I could take a spacecraft and fly through the upper parts of the atmosphere, there'd be swirls, there'd be powerful thunderstorms. I personally wouldn't take an airplane and fly into a hurricane. Well, the hurricanes on Jupiter are the size of the Earth. They're so powerful.
Some people call Jupiter a failed star, other people say no, it's a very successful planet. If Jupiter was maybe 30 times more massive, the heat in the center would be so intense that nuclear reactions could start, and it would be like a second sun in the solar system.
Long after the shockwaves from comet Shoemaker-Levy 9 had dissipated in Jupiter's stormy skies, the impacts were still being felt on Earth. We'd been jolted by a powerful reminder that the solar system can be a very dangerous place to live. No one is more aware of Earth's vulnerability in the cosmic shooting gallery than Gene Shoemaker, one of the comet's discoverers. He began carving out his scientific career here at Arizona's Meteor Crater in the 1950s.
Well, it turns out we're very lucky that Jupiter is there, because if Jupiter were not there, the flux of comets in the neighborhood of the Earth would be about 100 times or even possibly several hundred times higher than it is now. And so Jupiter does protect us from comets that are coming in from the very fringes of the solar system. It throws them out, it gets rid of them. And we would have catastrophic collisions about 100 times more frequently than has actually occurred over geologic time.
Carolyn and Gene Shoemaker have scoured the world, chronicling a pockmarked history of planet Earth. As a team, they're formidable, having now discovered more impact sites on Earth and more comets in space than anyone in history.
In fact, right over there you can see where it's turned up, peeled up, and passes right out into the debris. So that's the hinge line, right over there.
Mm-hmm. It's such a thrill to actually discover something that probably no one else has ever seen before, and to find a comet that was going to actually hit a planet, something that an event that we could actually see. That sort of left us all just thrilled. We had a real high, and we knew that we were going to learn things that we would never have a chance to learn otherwise.
For millennia, the bright beacon of Jupiter has caught the human gaze as it has traveled the heavens. But we had to wait for the invention of the telescope and a Renaissance Italian for the planet to begin giving up its secrets. On the night of January the 7th, 1610, Galileo Galilei made a discovery that was to challenge Earth's claim to sovereignty of the solar system. Focusing his telescope on Jupiter, Galileo saw bright points of light in close attendance, little stars that shifted position. The logic was inescapable. Jupiter had at least 4 moons of its own. Io, a festering boil of sulfur and rock. Europa, with a silver surface of pure ice. Ganymede, a world of grooves and frozen slush. And Callisto, with its catalogue of craters. Here, circling mighty Jupiter, is an entire planetary system in miniature. Jupiter's dominance of the solar system is complete. 1,300 times the size of the Earth. It's a world so enormous it could swallow every planet and moon in the solar system and still have room to spare. Looking back from Jupiter, the Earth is a feeble speck circling a faint and distant sun. Today, the descendants of Galileo's telescope populate mountaintops around the world, and his dreams inspire a new generation of astronomers.
What we see in the sky is the same thing that Galileo saw, and the reasons that we look, the reasons astronomers look in the sky, are the same reasons that Galileo looked. He was trying to find out what was happening out there.
This same quest also set amateur astronomer David Levy on the path to comet discovery and his eventual meeting with the Shoemakers.
I've been fascinated with Jupiter since the summer of 1960. That summer, I had my first telescope, and with my parents, I went outside, set it up, and looked up at the sky and saw the brightest star in the whole sky. So it had 4 little moons and little bands across it, and I said, "Hey, that's Jupiter." It's the first thing I ever looked at through a telescope. And I think if that particular night, if my dad had said, "You know, in 35 years from now, a comet with your name on it is going to go smashing into that planet," I would have been pretty surprised.
If 4 centuries ago, someone had told Galileo that a spacecraft bearing his name was going to follow in the comet's footsteps, he too would have been quite surprised. On the 7th of December, 1995, Galileo, in name and spirit, will reach out to touch the turbulent heart of Jupiter itself. Galileo, the spacecraft, is 3 tons of rocket and robot that will spend at least 2 years in the court of the king of the planets, locked in orbit as Jupiter's first artificial satellite. The spacecraft first took shape in the early 1980s at the Jet Propulsion Laboratory in Pasadena. It was a team effort. The main sections came from JPL and NASA's Ames Research Center. The rocket motor came from Germany, and the fine wire mesh of the main antenna had to be spun by a stocking factory. The end result, the largest and most ambitious unmanned planetary explorer NASA has ever put together. In overall mission command, JPL's Bill O'Neill.
It's a total commitment for the team at large. We are going to make this work. So we're going to do just a bang-up job on the Jupiter system. We're going to assault the Jupiter system with the most fantastic array of instrumentation you'd want to imagine.
NASA has assaulted the Jupiter system before. Back in 1979, 2 unmanned Voyager spacecraft made the long haul to Jupiter and its 16 moons. As they passed through this Jovian kingdom, they encountered a realm of alien worlds, the like of which we had never expected. Here were the 4 large moons of Galileo in close-up, the cracked shell of Europa, the strange grooved surface of Ganymede, heavily cratered Callisto, and the volcanic landscape of Io. These images left a powerful impression.
I can't get Io out of my mind. It was one of the first things we saw. We saw many beautiful things after that. But Io was so unexpected. Nobody had thought of any place having active volcanism on it other than the Earth. It was a feeling of almost seeing a new world every day when we were going through one of these encounters.
Strangest of all was Jupiter. Here, in intricate detail, was the fearsome beauty of the Great Red Spot, a hurricane 3 times the size of Earth. For some unfathomable reason, it's been raging for more than 300 years.
It was great being part of Voyager. A scientist really lives for surprises, discoveries, and Voyager just constantly provided them. I had known about the red spot and the 300-year-old storms, but then when I saw everything churning and bubbling and very active, it became harder to understand how these large storms could coexist with all this chaos.
The Voyagers brought home to Earth images of a majestic world that had tantalized astronomers for centuries, where strange spots glided across the surface and the clouds swirled like liquid marble. But for every mystery the Voyager spacecraft solved, they uncovered 1,000 more.
Voyager was, if you will, just a reconnaissance in force. But when you realize that, for instance, the very best pictures we have of the satellites of Jupiter from Voyager, beautiful as they are no better than what Galileo saw when he turned his telescope to the moon. And think about how much we've learned about the moon since then. It gives you some feeling for why we want to go back.
But the Galileo spacecraft is not simply returning to take pictures. It will also release a small automated probe which will sample Jupiter's atmosphere directly.
I stood next to the probe once at Hughes Aircraft, and to stand next to this object, which you know is going into the atmosphere of Jupiter and may become actually part of Jupiter, it's quite an interesting feeling, quite an exciting feeling.
This part of the Galileo mission will last only 75 minutes, but every minute will bring precious discoveries we can make no other way.
We hit the atmosphere at about 106,000 miles an hour. That's roughly fast enough to go from San Francisco to New York in less than 90 seconds. This is the most difficult atmospheric entry we've ever done. We have to hit the atmosphere at exactly the right angle. If we hit 1.5 degrees too shallow, the probe will skip out of the atmosphere. If we hit 1.5 degrees too steep, the probe will burn up.
These difficulties of mission design, though, soon paled with the problem of simply getting Galileo off the ground.
We have a cutoff.
Galileo was to be the first planetary mission to be launched by a space shuttle, and so all of the problems with that development were also problems for us.
First scheduled for a 1982 liftoff, Galileo missed one appointment with Jupiter after another. Each time the mission was sent back to the drawing board and the years slipped by. Then, 4 months before a May 1986 liftoff, the Challenger disaster brought the shuttle program to a standstill.
We have a report from the flight dynamics officer that the vehicle has exploded.
Jupiter had time to wait.
People's Army, all members of the aristocracy are to be arrested. Take him away.
We are the People's Army. All members of the aristocracy are to be arrested.
But comrade, I'm People's Army too.
You expect us to believe that? Take him away.
The mellow taste of Smirnoff Black.
We are People's Army. All members of the aristocracy.
Imperial Russia's best-kept secret.
The wonderful world of the techno junkie. Surf the net, sniff the future. What's your smiling? You know what I say? Grow up. Get this. Virtual lager, virtual bottle, virtual color. Literally no taste. Here's some hardware I interfaced with earlier. Colston pills. Apparently it's fitted with an obsolete component. Flavor.
Hey man, get wired.
Get a life.
Radian B Mineral Bath belongs to the comprehensive Radian B range. So not only can you relieve your rheumatic, muscular and general aches and pains with these pain-relieving products, but you can also treat yourself to a Radian B Mineral Bath and let the soothing effects of the warm water turn your aches into an ah.
Monsoon.
Out here, it takes 12 Earth years for Jupiter to orbit the Sun. Yet, it spins so fast that a day on Jupiter lasts less than 10 hours. But what really sets Jupiter apart from the Earth is that beneath its colorful clouds, there are no mountains to view and no solid surface to tread.
Unlike the Earth, which is made of solid rock, Jupiter is made of hydrogen gas. It doesn't even have a solid surface at all. We know that it's made of hydrogen because we can weigh it by its gravity, its effect on the moons that go around it, spacecraft that fly past, and it just doesn't weigh enough to be made of something solid rock.
If Jupiter were made of solid rock, it would weigh 4 times as much and its gravity would be even more stupendous. But being made of gas means that even astronomers are reduced to making best guesses about a world so alien it's beyond our experience. If we could make the impossible journey to the center of Jupiter, we would pass quickly through the turbulent clouds of the atmosphere. But instead of hitting the ground, we would probably dive into a dense maelstrom of hydrogen gas thousands of miles deep. As we descend and the pressure builds, the thickening gas is squashed into an ocean of liquid. And deeper still, into metal. Here, in the middle of Jupiter, is a churning sea of metallic hydrogen, generating an immense magnetic aura. It was towards this vast sphere of strangeness that in 1989, Galileo was finally headed.
5, 4, 3, 2, 1. We have ignition and liftoff of Atlantis and the Galileo spacecraft bound for Jupiter.
Being lifted into orbit was just the first stage of the most roundabout route that a spacecraft has ever taken to its destination. In the wake of the Challenger disaster, Galileo was released with a smaller-than-planned booster rocket that would only get it as far as Venus, in the wrong direction. To get all the way out to Jupiter, Galileo would have to swoop back past Earth twice, each time picking up a gravitational slingshot that would send it a little further out. The whole trip would take 6 years and cover nearly 2.5 billion miles. But the journey Shoemaker-Levy 9 had taken was even longer. "1929 was an auspicious year in astronomical circles. It was the year Caroline Shoemaker was born, and the year the comet made a critical shift in orbit. After 5 billion years doing lazy circles around the sun, Shoemaker-Levy 9 was to leave for a new master. 21 years before Caroline and Gene Shoemaker were to meet, the comet they were yet to discover strayed too close to Jupiter for comfort and fell under its gravitational spell. On March the 22nd, 1993, David Levy made a familiar trek to the summit of California's Palomar Mountain to join the Shoemakers in a continuing search for comets and asteroids.
It was a beautiful, clear night. I'm loading the telescope and exposing one film and then another picture and then a third and then a fourth, and then Gene Shoemaker calls from downstairs. He said, "David, somebody has opened the film box and all our film has been exposed to light."
Our hearts sank because it took 6 hours to prepare the next batch. So I quickly fished out a couple of films from the middle of the box and tested them in the dark room, and sure enough, they were light struck around the outside, but they were still usable in the middle. So we went on and completed the work. Well, the next night, our usual luck started coming back. The storm was coming. We got halfway through, and the clouds stopped us. David, ever the optimist, said, it isn't that bad. Maybe we ought to keep going. And I said, no, David, each one of these films costs us $4 a crack. We can't afford it. And that time, he had an idea. He says, don't we have some of that light-struck film left? I said, yes, we do.
I said, why don't we use those? They're not going to cost us anything. They're ruined anyway. We have nothing to waste but our time. And Gene and Carolyn and I looked at each other, and Gene said, let's do it. The very next film that I took with this telescope was the discovery film of Comet Shoemaker-Levy 9.
It was another 2 days before they realized what they had found. Carolyn had left the light fog plates until last.
And so I went ahead and I looked at that film. I do this very methodically. Started across the top, went back and forth. Saw the usual things I expect to see when Jupiter is on the field. And then I came to another something toward the middle of the field. And there was this most amazing image I had ever seen. I turned to the others and said, I don't know what I've got, but it looks like a squashed comet.
Carolyn's strange object needed a second opinion. With fine weather over Kitt Peak in southern Arizona, David Levy called his friend Jim Scotty, working at the Spacewatch telescope.
Hello? When I was able to point the telescope at where this weird object was supposed to be out by Jupiter, I took a scan, and it was apparent that it wasn't just a normal comet. It was a very unique object with a string of nuclei all in a row. David Levy finally called me back from Palomar. Well, I think he could tell by my tone of voice that something was a little bit out of the ordinary.
What had once been a single comet had now become a train of smaller fragments.
Could it have gotten too close to Jupiter and been broken up by tidal forces in Jupiter's gravity field?
That seemed like an explanation, but we thought, nah, it's not very probable.
And I said to myself, fat chance. He always told me I'd never see anything like that.
But that's exactly what they had seen.
If you're flying along in space, you're weightless. But if you fly past another object, your feet are feeling a little more pull than your head, and that tends to pull you apart, but very, very gently. The fact that Shoemaker Levy 9 got pulled apart by those tidal forces, just like the tides, means that it really was not held together very well at the start.
Of stronger stuff was Galileo. As it swooped towards Earth for its first gravitational slingshot, haunting signals swept up from thunderstorms on the planet below. Galileo was hearing the sound of lightning bolts rippling into the Earth's magnetic field. As it listened in, the spacecraft picked up the acceleration it needed and left at 80,000 miles an hour. On the way out, its camera sent back the ultimate home video, complete with glint of sunlight on water. But not every object out here is as well targeted or as well behaved. Jim Scotty takes more than a passing interest in things moving fast through space. As a Spacewatch astronomer, he commutes regularly to the summit of Arizona's Kitt Peak to look for comets and asteroids which might be heading in our direction. Jim is one of the small, dedicated band of skywatchers looking out for the doomsday asteroid.
Objects bigger than a kilometer, which we think are really the ones that we should really most be worried about, that can do the most damage, given enough time, sooner or later one of them will hit us. There are something like 1,500 to 2,000 of those objects on Earth crossing orbits, and we now know something like 100 of them.
The odds are that somewhere out there is another big lump of leftover solar system like Shoemaker Levy 9, a mile or more across, and heading not for Jupiter, but for us. It's happened before. The comet that is thought to have wiped out the dinosaurs was probably about 6 miles across.
We now believe that the impact history of our planet is intimately tied to the evolution of biology on Earth, that impacts have served to sort of reset the clock every so often by eliminating most species and creating lots of opportunities, lots of new ecological niches. So if there had not been a history of impacts, presumably evolution would have been different and perhaps would have proceeded much more slowly. On the other hand, if there were too many impacts, we could imagine a situation in which the Earth was periodically sterilized, life destroyed completely, in which case we wouldn't be here to discuss this problem at all.
History has shown that at the speed these things travel, even a small object is dangerous. The asteroid that crashed at Meteor Crater was no bigger than a 747.
50,000 years ago, this place was a featureless plain, probably with a pygmy forest of juniper and pinyon and maybe a few larger pine trees out here, the scene that you see behind me, but with trees on it. And then, out of the southeast came a brilliant meteor, growing brighter and brighter and brighter, and finally till it was vastly brighter than the sun, and then it plunged into the Earth, creating a shock wave then that threw out the rock, making this hole that you can see behind me. And then, of course, material was still carried up in a very large mushroom cloud and came showering back down, making a thin layer of fine material that scattered over the landscape.
Back at Mission Control, Bill O'Neill had a more immediate problem to worry about.
Hi, Jim.
Galileo's main link with Earth, the high-gain antenna, had been stowed for years longer than planned. Now it had failed to open properly on command.
We saw that the motors were drawing more current than they should have, and they kept running beyond the point where the antenna should clearly be open, and were cut off only by the backup computer sequence. So we knew we had a problem.
For a while, we were really afraid that we would be very limited in the type of mission we could perform. So we started asking questions and realized that the low-gain antenna actually provided us a lot of opportunity, since we could actually reprogram the spacecraft in flight, if you will, do brain surgery on it, and at the same time utilize our capabilities to improve the systems we have here on Earth, the receiving antennas. And the end result is that we'll be able to do a fantastic amount at Jupiter.
For Earth-bound scientists such as John Spencer, the postcards Galileo will send from the moons of Jupiter will be the next best thing to being there. First, Io. Jupiter's gravity exacts a heavy price for such close proximity.
The side of Io that faces Jupiter bulges about 6 miles into the air, and the surface goes up and down by tens of meters every day. That's an enormous amount of distortion of the interior, and it's like taking a paperclip and bending it backwards and forwards, and you generate heat in the place where it's bending, and that exact same process is producing prodigious amounts of heat inside Io.
This is a world of monstrous volcanoes and rivers of sulfur.
There's 100 times as much heat coming out of every square foot of Io as there is coming out of the Earth. The surface is covered in weird patterns of yellow and brown, different kinds of sulfur, we think. It's an unbelievable place.
Io is only the size of the Earth's moon, yet its largest volcano is twice as big as Texas. If Io is unbelievable, then Europa is enigmatic.
There are really strange things on top of the ice. There are curving ridges that have almost perfect geometrical shapes. We can't imagine how those could have formed. When you look at it from a distance, it looks like a cracked eggshell. The surface sort of looks like broken up sea ice on the Earth. That may actually be quite a good analogy, because a lot of people think that there is actually a liquid ocean beneath the ice on Europa.
The core of Europa should be being kept warm by the same tidal forces that heat Io. Underneath the frozen surface may be a warm saltwater ocean, perhaps 60 miles deep. It's just possible that strange creatures may swim the soot-dark seas of Europa.
Some people draw an analogy to black smokers on the Earth's ocean floor, where volcanic heat from the Earth's interior is able to support communities of life deep down on the ocean floor.
2 miles down, the animals of the Earth's deep-sea vents live an alien lifestyle, surviving on sulfur and heat rather than sunlight and plants.
If there's anywhere in the solar system where there might still be life other than the Earth, then Europa would be the place to bet.
Ganymede is different again, a two-toned world with stretch marks.
Ganymede is a very interesting place. It's the largest moon in the solar system. In fact, it's larger than the planet Mercury. Some of the parallel ridges that we see on Ganymede might be similar to some of the parallel ridges we see on a glacier on the Earth. Some areas are covered in strange trenches that snake for thousands of miles across the surface. There's been a lot of activity a long time ago.
Most similar to our own moon is Callisto.
Callisto is an interesting place because it's not interesting. There's no sign that it's ever done anything in its history except get hit by asteroids and comets and things, and so it's totally covered in craters. And this is weird because it's not too far away from Ganymede, which is a similar size, a similar composition, and Ganymede has a lot of activity on its surface. Callisto is just completely dead.
Someone can save you up to a third on a wide range of fine fragrances. Who can save you up to a third on fine fragrances? Boots.
Unique, with an inner fire. There's something irresistible about natural beauty. And there's no mistaking a brilliance that lasts forever.
Commercial Union. We won't make a drama out of a crisis.
Come up and see me to make me smile.
At Morrison's this Christmas, you'll find friendly personal service, low prices and hundreds of great offers throughout the store. A £1 carton of Cadbury's Roses, just $2.79. Morrison's Rich Fruit Christmas Pudding is only $1.49. Harvey's Bristol Cream is $4.79. A 15 variety pack of Walker's Crisps is only $1.99. So for great value, make it a Christmas to remember with Morrison's.
Protect your heating system as well as your sanity with Fernox. Available from DIY stores and plumbers merchants.
After 3 years in space, Galileo had made it as far as Earth for the second and last time. As it picked up acceleration for the final fling to Jupiter, it was within a fraction of a second and half a mile of where it was expected to be. But where was the comet? 2 months after its discovery, no one knew either its exact whereabouts or its final destination. At the Central Bureau for Astronomical Telegrams in Boston, Brian Marsden was busy calculating the trajectory of an object that was by now flying out of control.
having been near Jupiter once, of course, it could go near Jupiter again. And it was on the 22nd of May, 1993, Saturday afternoon, actually, that I felt confident that I knew that it would collide with Jupiter in July 1994, just 14 months later.
And it's only 10 minutes to sunset.
Whatever astronomical conjunctions had conspired to entrap the comet in Jupiter's powerful spell, the timing could not have been much better.
26:33, about 5 minutes.
After a daring repair mission to the Hubble Space Telescope, the Earth now had a telescope with unsurpassed clarity of vision. On the week of reckoning, the world's arsenal of telescopes prepared for impact. On mountaintops, in space, and in the air, more lenses were trained on the same part of the sky than ever before in history. Like bombers in formation, Shoemaker Levy 9 made its final approach. For most people back on Earth, the 16th of July started just as it always did. Here in the foothills of the Sierra Nevada mountains in southern Spain, another sunny day slowly ebbed away. Most of the locals oblivious to the drama unfolding in the heavens above. But high on the summit of Cala Alto, the telescopes were waiting. First in line for the view of the millennium. 400 million miles away, the pre-dawn cloud tops waited. It took 6 minutes for the rising plume to rotate into the sun and into view from Earth. It took another half an hour for the light from Jupiter to reach the telescopes waiting at Cala Alto in southern Spain. 40 minutes after the impact, the mighty flare of a titanic collision was seen for the first time by human eyes.
We had heard over the email network that a flash had been seen in the infrared, but we were observing at visible wavelengths, so we had no idea if we would see anything. And the very first picture that scrolled on the screen, there was this amazing impact site. Look at that! Look at that! And at the same time, there was that little press conference going on, and we could see Gene Shoemaker saying, well, we really don't know if we're going to see anything.
Surprise in hand, Heidi Hammel interrupted the press conference.
See these things at all, and I think we may have some up-to-date information from Heidi Hammel.
This was the start of a week of spectacular impacts. On the volcanic summit of Hawaii's Mauna Kea, many of the world's finest telescopes swung into action. At the world's largest telescope, the multifaceted Keck, Imke de Pater waited.
We saw first two little precursor flashes, followed by a much larger flare. The first precursor we saw is the meteor trail in the atmosphere. After the comet explodes, a fireball is sent up there, a hot fireball. So we think that that's the second precursor. And then the third big flare is when the stuff is being thrown up on basically ballistic trajectories, like when you throw a ball up. It comes down on the atmosphere, and when it falls down, it shocks and heats the atmosphere.
We were actually down in Australia at the Anglo-Australian Telescope. We were clear for 8 nights in a row, and so we got to see 8 of the impacts. We were actually choosing to observe with an infrared spectrometer. And the spectrometer is an instrument that takes light from Jupiter and then breaks it up into its constituent wavelengths. And you can think of them as colors, even though the human body can't see infrared, it can only feel it as heat. So the beauty of the infrared spectra we were taking was that in that wavelength range, in all those colors, we were able to pick up many, many molecules that are visible in comets and in Jupiter. So we were able to see initially material from Jupiter come up, things like methane and ammonia we saw first. And then after that, we saw something which was very amazing to us, which was a lot of carbon monoxide and water.
Theory had suggested these compounds existed on Jupiter. Now we could see for sure.
Waves spread out from that impact, just like ripples in a pond. The speed of the waves depends on how much water you have, and so we were hoping that by measuring the speed of the ripples, we could figure out how much water was on Jupiter. We were surprised because the waves were going faster than we thought, and that meant there was 10 times more water than we expected.
From Earth, we saw only the after effects of each collision, but still a year and a half from Jupiter, one camera had a clear line of sight. Galileo's observations of the impacts provided the critical link to the sequence of events. Each fragment punched a hole deep into Jupiter's clouds. Perhaps 50 miles below, the fireball exploded, sending a volatile plume of ejecta rocketing back up through the atmosphere. This plume, seen by the Hubble Space Telescope, rose more than 2,000 miles into space. When it crashed back down, it left a bruise the size of the Earth.
We were able to see happening in the Jovian atmosphere, right in front of our eyes, the kind of events that we had only speculated about in the past history of the Earth. If you had been in the atmosphere of Jupiter near the point of one of those impacts, you first would have been buffeted by a tremendous blast. Then about 20 minutes later, you would have been roasted from the heat of the infalling debris. In the case of the Earth, we believe that this falling material, which fell back over the whole planet, was the primary agent responsible for the death of the dinosaurs, that most of the dinosaurs on the surface would have been roasted within that first hour of the impact.
A year later, with the dust settled on Jupiter, the Galileo team prepared for an impact of their own making. Instructions for the orbiter to release the atmosphere probe were all pre-programmed. All mission control could do was wait for Galileo to signal success or failure.
If the probe could not be separated, it didn't just mean that we didn't have a probe mission, it also meant we didn't have an orbiter mission, because there's no way we could get the orbiter into orbit with the probe attached. So it was the whole enchilada. The probe had to separate or it was all over. So it was nervous to the max.
Nothing could stop the Galileo mission reaching Jupiter now. Next stop for the probe, the atmosphere on December the 7th, 1995. When the probe streaks into Jupiter's atmosphere, it will be going where no spacecraft has gone before.
Once we're on the main parachutes, we're above the ammonia ice clouds, and we'll probably see a blue sky above us and white clouds below us.
As you would get down lower, you would get into much thicker clouds of, we don't even know what they're made of, but things that have a brownish color may have some sulfur or some more ammonia in them.
There's ammonia, there's methane, there's sulfur, all kinds of these delightful things you really wouldn't want to be having a picnic in.
Below those cloud layers, however, we expect to see the water clouds, and these clouds could be quite thick, and in fact we could detect violent thunderstorms.
Some 75 minutes after it has entered the atmosphere, the probe's mission will be over, having reached a depth of more than 100 miles.
The probe will go well down beyond that. Exactly how far we don't know before it's destroyed, but it will be destroyed by the high temperatures and pressures eventually. Probably it will vaporize before it's crushed, and it will just all of a sudden vaporize and become part of Jupiter.
Like the comet before it, the probe will have become just another old piece of solar system sucked up by the gas giant.
Jupiter is the solar system's vacuum cleaner. If Jupiter weren't there, those comets would still be running around, smashing into all of the inner planets, including the Earth. The Earth would be being hit by comets instead of once every 100,000 years, might be being hit every 100 years or every 1,000 years. And we couldn't be here. We couldn't live on an Earth that was being smashed by a comet every 1,000 years.
For far longer than we've been aware, Jupiter has been playing the cosmic Hoover. Its massive gravitational power safeguarding our planet long enough for the human race to arise, and for people like Galileo to ask questions of the heavens above. The Galileo orbiter will end its days here in endless circles of the king planet, telegraphing answers for as long as its power supplies last. For 5 billion years, Jupiter has kept its secrets to itself. Now, in the closing years of the 20th century, we are set to finally discover what our most important neighbor is really like.
Experts are now on hand to answer your science questions raised by this programme. Call 0345 600 444. Lines are open for the next 2 hours and calls are charged at local rates. That's 0345 600 444.
X-Factor. That certain something that immediately makes us want a product. Whether it's a new kettle or the latest scooter, the search is always on for this elusive quality. Join top designers Seymour and Powell and witness the emergence of a classic bike, the BSA Bantam in its new form.
Voilà.
Ben était justement en train de me dire qu'il me trouvait pas très fidèle.
Bah, à propos de fidélité, Danny,